Hello students and good morning. So now I am doing class for class 12. The topic is relations. So in the last online class we did more examples on reflexive, symmetric and transitive relations. That is 3 types of relation. So today we will do more problems on these 3 types of relations, that is reflexive, symmetric and transitive. Okay. So now question number 1 is the relation R in the set capital A is equal to, here the set A is number, set A is numbers, that is A is equal to set A is equal to 1, 2, 3, 4, 5, 6 etc. up to 13, 14, right, is defined as, the relation R in the set A is defined as R is equal to within second bracket x comma y such that 3x minus y is equal to 0. Here the relation R is, the relation between x and y are given here, 3x minus y is equal to 0. All these x and y belong to the set A, right? Is the relation R reflexive, symmetric and transitive? You have to check whether the relation R is a reflexive, symmetric and transitive. So let us check whether the R is reflexive or not. Okay, for reflexive relation, right? For reflexive relation, what is the definition? Small a comma small a should belong to the relation R. Small a comma small a should belong to the relation R. You know that, isn't it? The relation R on a set A is said to be reflexive if within bracket a comma a belongs to R for all small a belong to the set capital A, isn't it? Now this x comma y, you should write it from 1, 2, 3, dot, 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 13, 14. Okay, so a comma a should belong to R. So you can take here 1 comma 1. We can take reflexive relation means 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6, 14 comma 14 should be there for reflexive. Okay. So let us check it. 1 comma 1, that is we can put x is equal to 1, y is equal to 1, that is we can put x is equal to 1 and y is equal to 1. If we put x is equal to 1 and y is equal to 1, you check whether this relation holds or not, that is 3x minus y is equal to 0 or not. Let us check it. Therefore 3x minus y is equal to 3 into 1 minus 1, which is equal to 3 minus 1 is equal to 2. That is not equal to 0. That means 1 comma 1 does not satisfy this equation, that is 3x minus y is equal to 0. That means 1 comma 1 does not belong to the relation R. So एउटा example is sufficient भइगयो, it is not reflexive. तो अरु चेक गरिरहनै पर्दैन, ठीक छ? Therefore the relation R is not reflexive. The relation R is not reflexive. Is that clear to all of you? तो यहाँ जुन चाहिँ relation R दिएको थियो, that is not your reflexive. Is that clear now? So next, बुझ्यो होला तिमीले यो? लो अब हामी अर्को चेक गर्छौं, symmetric relation. Whether the relation R is symmetric or not, you have to check it. Okay? Now, symmetric relation. So what is the definition of symmetric relation? If a comma b belongs to R, then it should imply b comma a should belong to the relation R. So symmetric relation says that, what is the definition? If a comma b belongs to the relation R, it should imply b comma a should belong to the relation R. Ulta, b agadi, a pachadi. It should also belong to R. Okay, if AB belongs to capital R implies that B comma A belongs to R, then the relation R is a symmetric relation. So now let us check it. So x comma y. So x is equal to कति, x is equal to कति, y is equal to कति हाल्दा फेरि यो 0 हुन्छ. X is equal to 1 र 3. So 1 comma 3. That is you put x is equal to 1, y is equal to 3 in the relation. that is 3x minus y is equal to, how much is it now? 3 into 1 minus y is 3, which is equal to 0. That means 1 comma 3 belongs to the relation R. So 1 comma 3 belongs to R, right? Now 3 comma 1 should belong to R for the symmetric relation, isn't it? So now 3 comma 1, let us check it now. That is x is equal to 3 and y is equal to 1. So x is equal to 3, y is equal to 1. So let us put here 3x minus y. So let us put in the expression 3x minus y and check it whether it is equal to 0 or not. So is equal to, this is 3 minus 1 is equal to 3 3s are 9. 3 3s are 9 minus 1, which is equal to 8, but not equal to 0. It should be equal to 0. That means 3 comma 1, that is 3 comma 1 does not belong to the relation R. Is that clear? That means what can we say about the relation R? It is also not symmetric. Is that clear? Therefore, the relation R is not symmetric. Therefore, the relation R is not symmetric. The relation R is not symmetric. Yo R relation symmetric pani hoina. बुझ्दैछ सबैले? I think I have understood this symmetric relation. अब transitivity check गर्नु. Transitive relation check गर्नु अब. Now transitive relation. Now transitive relation यो check गर्ने अब. So transitive relation को definition के हो? If A comma B belongs to the relation and B comma C belongs to the relation R, then A comma C should belong to the relation R. Okay, so this is the definition for transitive relation. So let us check it now. So if you write here 1 comma 3, if you put x is equal to 1, y is equal to 3, you can take it from the set A. If you put x is equal to 1, y is equal to 3, this 3 minus 3 is 0, you can take it, right? So let us take therefore 1 comma 3, 1 comma 3, right? That is x is equal to 1, y is equal to 3. So let us put these values in the expression 3x minus y, which is equal to 3 1s are 3 minus 3, which is equal to 3 minus 3 is equal to 0. That is, we are getting 0. Next, अब हामी यो b कति हाल्छौ? 3 हाल्छौ. c यो y कति हाल्दा चाहिँ 0 हुन्छ अब. So if you put now a comma b, b comma c should be there. So 1 comma 3 is there. Now 3 3s are 9, minus 9 is 0. So now we can put 1 comma 9. Oh, sorry, 1 comma 9. It's not 1 comma 9. It should be 3 comma 9. If it is a comma b, it should be b comma c. यो b repeat हुनु पर्यो अब. यहाँ b repeat भनेको 3 repeat भइगयो 3. यहाँ 3 3s are 9 minus कति 0 हुन्छ? 9. You can put 9. 3 comma 9. That is x is equal to 3, y is equal to 9. Is that clear? So let us put these values in the expression 3x minus y and it should be equal to 0. So 3x minus y is equal to 3 into 3 minus y is 9. We can put 9, which is equal to 9 minus 9 is equal to 0. So 1 comma 3 belongs to R, 3 comma 9 belongs to R. So 1 comma 9 should belong to R. Okay. So here in this case 1 comma 3 belongs to R, right? 1 comma 3 belongs to the relation R. किनभने 3x minus y is equal to 0 and 3 comma 9 also belongs to R because 3x minus y is equal to 0 in this case also. Okay, so 3 comma 9 belongs to R. Now can you say that 1 comma 9 belong to this relation R? So let us check it. Now 3 comma 9, let us check it. So therefore 3x minus y, that means instead of x you put 3, oh not 3 comma 9, sorry, not 3 comma 9. यो 3 र 3 त छोड्यो नि अब. कुन कुन रह्यो 1, 9 should belong to R. In order to have a transitive relation, 1, 9 should belong to R. Is that clear? If 1, 3 belongs to R and 3, 9 belongs to R, the transitive relation is that 1, 9 should belong to R. That is 1, 9. Let us check it. Here x is equal to 1 and y is equal to 9. X is equal to 1, y is equal to 9. So let us check it here. So 3x minus y is equal to 3 into 1 minus 9. Right? X is equal to 1 here, y is 9 here. So it is 3 ones are 3 minus 9, which is equal to minus 6. So which is not equal to what? Which is not equal to 0. Right? If you put x is equal to 1 here and y is equal to 9 here, this will be 3 ones are 3 minus 9, which is equal to minus 6, which is not equal to 0. So यो 0 हुनु पर्ने थियो तर 0 आएन, which is not equal to 0. That means what can you write here? 1, 9 does not belong to R. That means it is not transitive relation. So therefore the relation R, therefore you can write the relation R is not a transitive relation. The relation R is not a transitive relation. The relation R is also not a transitive relation. You are transitive relation pani hoina. Okay? The relation R is not transitive relation also. Is that clear? So in this case, the relation R is neither reflexive nor symmetric nor transitive. Kunai pani relation bhaena yo. So I think you have understood it. You can copy it. So now we'll do the next problem. So now we'll do the next question, that is question number 2. Relation R in the set n of natural numbers defined as capital R is equal to, here the relation R is defined as x comma y such that y is equal to x plus 5 and x should be strictly less than 4. Natural number means it will start from number 1. Positive 1, 2, 3, 4, 5, 6, etc. These are all natural numbers. Plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, etc. These are all natural numbers. Okay? And here x is less than 4. And there is a relation between x and y in which y is equal to x plus 5. So you have to check whether R is reflexive, symmetric and transitive. You have to check it. Okay? So now let us check for reflexive. For reflexive relation, what is the definition? A comma A should belong to R. A comma A should belong to R. Now let us check 1 comma 1. X is less than 1. So 1 comma 1 should satisfy this relation. Will it satisfy the relation? 1 comma 1, will it satisfy this relation 1 comma 1? 1 is equal to, that is, this is x is 1 plus 5. 1 plus 5 is equal to 1. That is, x is equal to 1, y is equal to 1. Reflexive means 1 comma 1, 1 comma 1, 2 comma 2, 3 comma 3, etc. should belong to this relation R. So let us check it. So 1 is equal to 1 plus 5. Is it equal? No. 1 is equal to 6. They are not equal. So 1 comma 1 does not belong to R. So what can we say about the relation R? The relation R is not reflexive. Okay. Therefore, the relation R is not reflexive. The relation R is not reflexive. Is that clear now? So next, symmetric. So is that clear to all of you? The relation R is not reflexive in this case because 1 comma 1 does not belong to the relation R. Okay. सो यही एउटा एक्जाम्पलले नै काफी हुन्छ कि यो रिफ्लेक्सिभ हुँदैन भनेर बुझ्यौ 2,2 हाल्यो भने तिमीले 2,2 x is equal to यो पनि 2 हुन्छ 2 not equal to 7 3 हाल्यो भने नि 3 is equal to 8 हुँदैन 4 हाल्यो भने हुँदैन 4,4 does not belong to R like that okay so यो एउटै एक्जाम्पल दियो भने एउटै एक्जाम्पल यो 1,1 does not belong to R यही मात्रै तिमीले देखायो भने भइगयो the relation R is not reflexive ठीक छ अब symmetric now symmetric मा the symmetric मा चाहिँ के गर्नु पर्छ भन्दा फेरि now for symmetric if A comma B belongs to R then it should imply B comma A should belong to R this is the symmetric relation isn't it if A comma B belongs to R then B comma A should belong to R ulta B comma A should belong to R okay so if you put x is equal to 1 if you put x is equal to 1 x is less than 4 bandais x less than 4 मात्रै हाल्नु पर्छ but n here is a natural number only you can put 1 2 3 and so on 1 2 3 only you can put 1 2 and 3 only not more than 3 okay x less than 4 भने तिमीले x is equal to 1 2 3 मात्रै हाल्नु सक्छ that is also natural number that's why we can put x is equal to 1 2 3 so let us put x is equal to 1 so 1 comma if you put x is equal to 1 y is equal to 6 isn't it so 1 comma 6 that is if you put 1 x is equal to 1 plus 5 is equal to y is that is your 6 okay so now 1 comma 6 belongs to the relation R so can you say that 6 comma 1 belong to R now can you say that 6 comma 1 belong to R so let us check it 6 comma 1 means so 6 comma 1 so let us check it now x is equal to 6 this is 6 plus 5 this is your 6 plus 5 is equal to what is y here this is 1 is it equal so 1 is not equal to 6 plus 5 that is 11 so that is 6 comma 1 does not belong to R 6 comma 1 does not belong to R the x is equal to 6 पनि लिनै भएन x is equal to 6 पनि लिनै हुँदैन हैन 6 comma 1 पनि लिनु भएन so 6 comma 1 यहाँ हुँदैन हैन त 1 comma 6 छ भने 6 comma 1 हुँदैन does not belong to R that means the relation R is not symmetric so therefore the relation R is not symmetric the relation R is not symmetric is that clear now the relation R is not symmetric यहाँ symmetric भएन ठीक छ अब हामी के चेक गर्छौं ट्रान्जिटिभ चेक गर्छौं now transitive now let us check the transitivity of the relation R okay so what is transitive relation if A comma B belongs to R and B comma C belongs to R it should imply that A comma C belong to R A comma C belong to R यसलाई यसै लेख्दा पनि हुन्छ A is in relation with B and B is in relation with C should imply that A is in relation with C यो दुईटा एउटै हो either you can write down this expression for transitivity or you can write down this expression for transitivity is that clear this is all same A is in relation with B and B is in relation with C should imply A is in relation with C for the transitive relation okay so now let us check it now so if you put x is equal to 1 x less than 4 1 so you can put x is equal to 1 so y is equal to 6 is there okay so 1 comma 6 1 comma 6 that is this x is equal to 1 1 plus 5 is equal to 1 plus 5 is 6 that means 1 comma 6 belongs to the relation R Therefore 1 comma 6 belongs to the relation R. The अब 6 को हुन्छ यहाँ. Can you put x is equal to 6 here? You cannot put x is equal to 6 in this case. So you cannot put here x is equal to 6 as x is less than 4. So 1 comma 6 belongs to the relation R. अर्को 6 comma को relation नै आउँदैन यहाँ. त 6 comma को relation आयो भने त्यो हेर्नै पर्दैन, डाइरेक्ट यो ट्रान्जिटिभ रिलेसन भइहाल्छ. त अस्ति लास्ट अनलाइन क्लासमा मैले के भनेको थिएँ भन्दाखेरि a comma b रिलेसन a comma b belongs to the relation छ, तर यो छैन भने ट्रान्जिटिभ भइगयो. बुझ्यो? बुझेन? यो दुईटै छैन भने पनि त्यो ट्रान्जिटिभ रिलेसन भइहाल्छ. त a comma b belongs to relation नै छैन भने यो चेक गर्नै पर्दैन. That is also transitive relation. Is that clear? तर यो दुईटै छ. A comma b belongs to relation R, b comma c belongs to relation R छ भने a comma c should belong to R relation हुनै पर्छ. नत्र भने त्यो ट्रान्जिटिभ रिलेसन हुँदैन. तर a comma b belongs to relation छ तर b comma c रिलेसन छैन भने हामीले त्यो हेरिरहनु पर्दैन, डाइरेक्ट त्यो केमा आउँछ ट्रान्जिटिभ रिलेसनमा आइहाल्छ. भनेपछि यो 1 comma 6 belongs to the relation R छ तर 6 comma something हामी निकाल्न सक्दैनौं किनभने x is less than 4 छ, x is equal to 6 हाल्नु हामीले सक्दैनौं. त भनेपछि यो के भयो? दिस इज अ ट्रान्जिटिभ रिलेसन. डाइरेक्ट हामी के लेख्न सक्छौं? दिस रिलेसन R is a transitive relation. Therefore the relation R is a transitive relation. The relation R, that is the relation R is a transitive relation. तो यो तिमीको रिफ्लेक्सिभ रिलेसन हैन R, यो R सिमेट्रिक रिलेसन पनि हैन, तर R चाहिँ कस्तो खाले रिलेसन रहेछ? R is a transitive relation. Is that clear to all of you? बुझ्यो होला तिमीले हैन? फेरि पनि म भन्दै छु 1 comma 6 belongs to the relation R. फेरि हामी त्यो x को जग्गामा फेरि 6 हाल्नु पर्यो किनभने यहाँ b भनेको 6 छ, त यो b भनेको 6 हाल्नु पर्यो. यहाँ 6 हाल्नु सक्दैनौ हामीले किनभने 6 त आउँदैन नि त त्यहाँ. बुझ्नु भएन? 6 आएन भने हामी यो 1 comma 6 comma something बनाउन सक्दैनौ. बुझ्नु भएन? त यसमा तिमीहरुको यो डाइरेक्टली 1 comma 6 belongs to R छ तर 6 comma something छैन भने चाहिँ डाइरेक्टली यो के भयो? ट्रान्जिटिभ रिलेसन भइगयो. त यो एउटा कुरा चाहिँ राम्रोसँग याद गर्नुपर्छ. बुझ्यो यो? सो द रिलेसन R is a transitive relation, डाइरेक्ट भइहाल्छ. Is that clear now? So you can copy it. So now we'll do the next question. So now we will do the next question, that is question number 3. Relation R in the set capital A is equal to, set A is equal to, it is the collection of 6 integers from 1 till 6, that is 1, 2, 3, 4, 5, 6, is defined as R is equal to x comma y such that y is divisible by x. That is, this second number y is divisible by this first number x. That means x divides y. Y is divisible by x भनेको x divides y. x ले y लाई divide गर्न सकिन्छ. So is the relation R reflexive, symmetric and transitive? So you have to check it. Okay? Is the relation R reflexive, symmetric and transitive? So you have to check it. Okay? Now for reflexive. Now this is the solution. So for reflexive, you know the definition, A comma A should belong to capital R. Okay? So let us take 1 comma 1. Let us take 1 comma 1. That is, x is equal to 1, y is equal to 1. So y is divisible by x. So 1 is divisible by 1. You know that. 1 is divisible by 1. 2 is also divisible by 2, 3 is also divisible by 3, 4 is also divisible by 4, 5 is also divisible by 5, 6 is also divisible by 6 and so on. Right? So here what can I write? So therefore A is divisible by A. You know that, isn't it? A is divisible by A. A is divisible by A. That means A comma A belongs to R. Therefore the relation R is reflexive. The relation R is what? Reflexive. So I think you have understood it. The relation R is reflexive. Now we check on symmetric. So let us check for symmetric. Let us check for symmetric relation. So what is symmetric relation? A comma B belongs to R should imply that B comma A should belong to R. Suppose B is divisible by A. Suppose B is divisible by A. So what does it indicate? A comma B such that B is divisible by A. That is B is divisible by A. B is divisible by A. Can you say that A is divisible by B? So can you say B comma A such that A is divisible by B? A is divisible by B. No, you cannot say it. So suppose if you have, suppose 2 comma 3. So let us take an example. Let us take an example now. 2 comma 4. 2 comma 4. Right? So what does it indicate? It implies that 4 is divisible by 2. 4 is divisible by 2. It's correct, isn't it? That is 4 is divisible by 2. This 4 is divisible by 2. So can you say this one 4 comma 2? Can you say that 2 is divisible by 4? 4 ले 2 लाई divide हुन्छ. 2 is divisible by 4. Is 2 divisible by 4? No, this is wrong. 2 is not divisible by 4. 2 is divisible by 4 हुन्छ कि हुँदैन. 2 is not divisible by 4. 4 ले 2 लाई divide हुँदैन. That means 2 comma 4 belongs to R, but 4 comma 2 does not belong to R. That means the relation R is not symmetric. Therefore, the relation R is not symmetric. The relation R is not symmetric. So I think I understood it. The relation R is not symmetric. But the relation R is reflexive, but the relation R is not symmetric. Okay? So now let us check for transitivity. So transitive. So for transitive now, for transitive, what is transitive relation? What is transitive relation now? If A comma B belongs to R and B comma C belongs to R, then what? A comma C belongs to R. अब यो B लाई छोड्नु पर्यो. So A comma C belongs to R. Right? If A comma B belongs to R and B comma C belongs to R, then A comma C belongs to R. Okay? So here, therefore 1 comma 3. So what is meant by it? Let us take an example. So let us take an example here. 1 comma 3. Right? So 1 comma 3. This 1 comma 3. This 1 comma 3 belongs to what? This 1 comma 3 belongs to the relation R. 1 comma 3 belongs to R because 3 is divisible by 1. Isn't it? So 1 comma 3 belongs to R means y is divisible by x. That is 3 is divisible by 1. Yes. 3 is divisible by 1. You know that, isn't it? 3 is divisible by 1. And now let us take 3 again. Let us take 3 comma 6. 3 comma 6. That is y is divisible by x. That is 6 is divisible by 3. Belongs to R. Which implies that 1 comma 6 belongs to R. Is it true? That is 6 is divisible by 1. Is that clear now? Yo 3 लाई 1 ले divide हुन्छ. Yo 3 लाई 1 ले divide हुन्छ. फेरि यहाँ 3 ले 6 लाई फेरि 3 ले divide हुन्छ. That means it belongs to R. So you 1 comma 6 belongs to R. That means 6 is divisible by 1, isn't it? So it belongs to R. So it is transitive. Is that clear? Similarly, also say an example. 1 comma 2 belongs to R. 2 is divisible by 1. 2 is divisible by 1. This relation, your relation y is divisible by x. That is 2 is divisible by 1. So 1 comma 2 belongs to R, and what? 2 comma then 2 comma 4. 2 comma 4, right? So 2 comma 4 also belongs to R because this 4 is divisible by 2. बुझ्नु पर्छ है यहाँ राम्रोसँग हेर्नु एक्जाम्पल 1 comma 2 भनेपछि यहाँ 1 comma 2 लगाएपछि y is divisible by x भनेको 2 is divisible by 1, right? And फेरि यो 2 ले पनि यहाँ के लिन्छ 2 नै लिनु पर्यो अनि यहाँ 4 लिनु किनभने 4 is divisible by 2. Can you say that 1 comma 4 belongs to R? That is naturally 4 is divisible by 1. 4 is divisible by 1. Is that clear now? So this is also transitive relation. Okay, अब अर्को एउटा चेक गरौँ. 2 comma 4 belongs to the relation R, right? That is 4 is divisible by 2. It belongs to the relation R. 4 is divisible by 2. It belongs to the relation R. So 4 comma के हुनु 8 हुनु पर्ने थियो. But is there 8? छैन. त अर्को तिमीको 4 comma something नै छैन भने यो हेर्नै पर्दैन तिमीले. यो हेर्नै पर्दैन, यो डाइरेक्ट ट्रान्जिटिभ रिलेसन आइहाल्छ. यो दुईटाले गर्दा नै यो के भयो ट्रान्जिटिभ रिलेसन भइगयो. बुझ्यौ? त 2 comma 4 belongs to R. So R comma 8 हुनु पर्ने थियो, तर 8 तिमीले लिन सक्दैनौ. त्यो हुँदैन पनि. बुझ्यौ न? 4 comma 8 लिनु सक्दैन किनभने 8 सेट A मा पर्दैन. त त्यो सेकेन्ड रिलेसन छैन. अघि नै मैले भने A comma B belongs to R, तर B comma C belongs to R छैन भने डाइरेक्ट ट्रान्जिटिभ रिलेसन. Is that clear? So यो तिमीले हेरिरहनु पर्दैन. भनेपछि हामी डाइरेक्ट के लिन्छौ? The relation R is a transitive relation. Therefore, the relation R is a transitive relation. The relation R is a transitive relation. So, is that clear to all of you? The relation R is a transitive relation. बुझ्यो तिमीले यो? त भनेपछि यो रिलेसनमा हामीले के देख्यौं? R चाहिँ रिफ्लेक्सिभ रिलेसन अनि ट्रान्जिटिभ रिलेसन हो, तर यो के रिलेसन होइन? सिमेट्रिक रिलेसन चाहिँ होइन. Is that understood now? So you can copy it. Now we'll do the next problem now. So now we'll do the next problem, that is question number 4. The relation R in the set Z of all integers. The set Z denotes the set of integers. Integers means it may be positive integers, it may be negative integers including 0. Okay, 0 is also an integer. Is defined as capital R is equal to within second bracket x comma y such that x minus y is an integer. The difference of x and y, that is x minus y, should be an integer, right? This is the relation. Is R reflexive, symmetric and transitive? So let us check it. So for reflexive relation, For reflexive relation, we have A comma A should belong to the relation R. Okay? So A comma A should be related to itself. That is A minus A. A minus A is equal to what? 0. That is 0 is an integer, you know that, isn't it? So 0 is an integer. So 0 is an integer. That is A comma A belongs to the relation R. That is 1 minus 1 is 0, 2 minus 2 is 0, 3 minus 3 is 0, 4 minus 4 is 0, 4 minus 4 is 0. You can take minus 1 and minus 1. What is the difference? You can take minus 1 comma minus 1 also, isn't it? So which is equal to minus 1 comma minus 1 is equal to minus 1 plus 1, which is equal to 0. So minus 1 comma minus 1 also belongs to the relation R. So here the relation R is a reflexive relation. Okay. So therefore the relation R is a reflexive relation. The relation R is a reflexive relation. तो यो R चाहिँ रिफ्लेक्सिभ रिलेसन हो. ठीक छ. अब सिमेट्रिक रिलेसनमा जाउँ. Symmetric relation. So what is symmetric relation now? If A comma B belongs to relation R, then B comma A should belong to the relation R. Okay? So that is if you take A and B. So if A and B are integers, right? So A minus B is an integer. So therefore A minus B is an integer, right? A minus B is an integer. So B minus A is also an integer, isn't it? So therefore यसलाई उल्टाबाट भन्दा कसरी भन्छौ? B minus A. So B minus A पनि के हुन्छ? B minus A is an integer. B minus A पनि के भयो? Integer नै हुन्छ. जस्तै तिमीले लिनु पर्यो 4 and 10. If you take 4 and 10, 4 minus 10 is minus 6 is an integer. त्यसलाई उल्टा बनाऊ. 10 minus 4 पनि कति भयो? 6 नै भयो. 6 is also an integer. The negative पनि आउन सक्छ, यो positive पनि आउन सक्छ. भनेपछि यो कसको रिलेसन भयो? So this is a symmetric relation. Therefore the relation R is a symmetric relation. The relation R is a symmetric relation. So I think you have understood it. Okay. So it is a symmetric relation. अब हामी transitive relation पट्टि जाउँ. So I think you have understood it. Okay. So let us take transitive relation. Now for transitive relation, you know that अच्छा यस्तो पाराले लेख्दा पनि हुन्छ भन्ने थिएँ मैले अघि. If A is in relation with B and B is in relation with C, which implies that A is in relation with C, isn't it? If A is in relation with B and B is in relation with C, which implies that A is in relation with C. Is that clear now? So this is your transitive relation. So over here, if A is in relation with B, we can write down that A minus B is an integer. A minus B is an integer. A minus B is an integer. Okay. So also B minus C is an integer. B minus C is also an integer. Right. So let us add them. Therefore, A is in relation with B means A minus B is an integer by definition. For A comma B, or A is in relation with B, what can you write? A minus B is an integer. Okay. So B is in relation with C means B comma C means B minus C is an integer. So A comma C should belong to the relation R. Okay. So we can add these two, A minus B plus B minus C. That is This is also integer, this is also integer. Integer plus integer is equal to integer. Integer plus integer is equal to some integer is there, isn't it? So which is equal to here, BB gets cancels. So what do we get? A minus C is an integer. A minus C is an integer. That is, A is in relation with B. That is, A is in relation with C. A minus C is an integer means A is in relation with C. So this is a transitive relation. So the relation R is a transitive relation. Is a transitive relation. Is that clear? So in this case, the relation R, x comma y, that is x minus y is an integer, is reflexive relation, symmetric relation and transitive relation. So it is an equivalence relation. I told you about the definition of equivalence relation. The relation R on a set A is said to be equivalence relation if it is reflexive, symmetric and transitive. यदि कुनै पनि relation R मा reflexive, symmetric र transitive relation तीनटै छ भने त्यसलाई के भनिन्छ? Equivalence relation भनेर भनिन्छ. ठीक छ? त यसमा यो R reflexive relation पनि भयो, symmetric relation पनि भयो, transitive relation पनि भयो. भनेपछि यो R is an equivalence relation. So is that clear to all of you? So you can note it down. So now we'll do the next problem. So now we'll do the next question, that is question number 5. So this is very, very important question, number 5. So that the relation R in the set R dash real numbers. Your R dash se ke ho? It is real numbers. Real numbers bhaneko all defined numbers. You can have integers, you can have fractions, you can have within a square root positive number. These are all defined numbers, that is real numbers. Okay. यो युनिभर्समा जति पनि नम्बर्सहरु छ सबै रियल नम्बर्स हो. It may be in terms of fraction, it may be positive integers, it may be negative integers including 0, it may be fraction, it may be decimal fractions, it may be within a square root positive number and so on. These are all your real numbers. Okay. It is defined as capital R is equal to within second bracket A comma B. These are all real numbers, A comma B, right? Such that a small a less than or equal to b square is neither reflexive, symmetric nor transitive. Is neither reflexive, symmetric nor it is transitive. You have to prove R is not reflexive relation, R is not symmetric relation and R is not transitive relation. So I think you have understood it. Okay. So let us check for reflexive relation. So for reflexive relation, you know that A comma A should belong to the relation R. Okay. So if you take, suppose if you take positive whole number, suppose if you take A is equal to 2, right? Suppose if you take A is equal to 2, also you have to take A is equal to 2, right? Is it true? So instead of A you have to put 2 less than or equal to B is also 2, because same numbers should be there. A is related to A. This means 2 is related to 2 whole square. 2 less than or equal to 4 square. So it is correct. So A ले चाहिँ के बुझाउँदैछ? Reflexive relation हो भन्ने बुझाउँदैछ यो रियल नम्बरले चाहिँ. यदि तिमीले पोजिटिभ नम्बर हाल्यो भने चाहिँ यो ट्रू भनेर देखाउँदैछ, तर यहाँ के देखाउँदैछ? इज नट रिफ्लेक्सिभ भनेर देखाउँदैछ. अब यो नट रिफ्लेक्सिभ चाहिँ कसरी देखाउँछ भन्दाखेरि यहाँ रियल नम्बर्स भने त तिमीले फ्र्याक्सन पनि हाल्न सक्छौ नि त, हैन? रियल नम्बर भनेपछि के पनि हाल्न सक्छ अरे? फ्र्याक्सन पनि हाल्न सक्छौ. अब चाहिँ हामी के गर्छौं? A इज इक्वल टु पनि हाफ हाल्ने अनि B इज इक्वल टु पनि हाफ हाल्ने. सेम नम्बर हाल्छौ नि त. अब हेर, यो हाफ अफ हाल्दा चाहिँ के हुन्छ भन्दाखेरि दिस इज हाफ लेस देन और इक्वल टु हाफ होल स्क्वायर, राइट? सो और दिस इज योर हाफ लेस देन और इक्वल टु 1/4. अघि चाहिँ हामीले कति हालेको थियो 2 2 हालेको थियो so 2 less than or equal to 2 whole square that is 2 is less than or equal to 4 so it is correct reflexive relation देखाउँदै थियो अहिलेको एक्जाम्पलमा चाहिँ तर अब चाहिँ के हुन्छ a is equal to half हाल्यो b पनि सेम हाल्नु पर्यो half for reflexive relation okay so if you put here half less than or equal to half whole square or half less than or equal to 1/4 is it true यो 1.1/2 भनेको कति हो 0.5 you know that यो भनेको कति हो 0.25 so which one is greater this one is greater 0.5 is greater than 0.25 but is 0.5 less than 0.25 no that is wrong is that clear so a is equal to half b is equal to half already does it belong to the relation r यो a less than or equal to b square हुन्छ no okay so therefore so this is not true right because this is not true because 0.5 is greater than 0.25 तर हामीले के देख्दैछौं 0.25 is more than 0.5 भनेर देख्दैछौं that is wrong is that clear so therefore the relation R is not reflexive. The relation R is not reflexive. So I think you have understood it. Okay. So you can copy it. So अब next हामी केमा गर्छौं अब हामी के चेक गर्छौं symmetric relation check गर्छौं ठीक छ so let us check for symmetric relation now symmetric relation so let us check for symmetric relation now so symmetric relation is a comma b belongs to the relation R implies that b comma a should belong to the relation R. Is that clear to all of you? The definition of symmetric relation is that a comma b belongs to R implies that b comma a belongs to the relation R. Okay? Now in this case a and b are real numbers. A and b are real numbers, right? So let us check for a is equal to -1 b is equal to 3 okay so let us take an example a is equal to -1 b is equal to 3 so here a less than or equal to b square or now a is -1 less than or equal to what is b square this is your 3 square or -1 less than or equal to 9 that is right 9 is greater than -1 अब यसलाई हामी उल्टा बनाऊ अब उल्टा भनेको a is equal to 3 b is equal to -1 हालौं so here ab belongs to r भइगयो यो ab belongs to r अब यसलाई उल्टा बनाएर गरौं अब उल्टा भनेको a is equal to 3 हाल्छ त्यहाँदेखि b is equal to के हाल्छ -1 हाल्छ अब a is equal to 3 हाल्नु पर्यो अनि b is equal to -1 हाल्नु पर्यो उल्टा भयो त अब के हुन्छ a is equal to 3 less than or equal to what is b square here you can put a less than or equal to b square ठीक छ अब a को सँग के हाल्नु पर्यो 3 हाल्नु पर्यो उल्टा 3 less than or equal to b square भनेको त्यो -1 whole square or 3 less than or equal to +1 is it correct is 1 greater than 3 no 1 is less than 3 so this is wrong so in this case this 3 comma -1 in this case -1 comma 3 belongs to the relation R -1 comma 3 belongs to the relation R but 3 comma -1 does not belong to the relation R but see the relation R is not symmetric therefore the relation R is not symmetric. The relation R is not symmetric. So we have proved it. Okay, the relation R is not symmetric. So you can note it down. So now we will check for transitive. Now we will check for transitive. So now let us check for transitive relation now. Now transitive relation. Okay. Now for transitive relation. So what is the definition of transitive relation? If A comma B belongs to the relation R and B comma C belongs to the relation R, it should imply that A comma C belongs to the relation R. Okay. So now let us take an example. So in this case here, A comma B should belong to the relation R. A comma B should belong to the relation R. A comma B should belong to the relation R. Okay. So let us take an example now. So let us take an example here. Let us take an example here. Let us take an example A comma B. Suppose A is equal to 2 and B is equal to minus 3. A is equal to 2 and B is equal to minus 3, right? So A less than or equal to B square. A less than or equal to B square. Does it satisfy this relation? Let us check it. A less than or equal to B square, or A here is 2 less than or equal to, what is B whole square? Minus 3 whole square. Or now this is 2 less than or equal to 9. So obviously 9 is greater than 2. Isn't it? That means we can write here 2 comma minus 3 belongs to the relation R. Now here A is equal to 2, B is equal to minus 3. We are giving the example, right? A is equal to 2 and B is equal to minus 3. A less than or equal to B square. So this A is equal to 2 and B is equal to minus 3 should hold this relation. That is A less than or equal to B square. So you put A is equal to 2 less than or equal to B is equal to minus 3 whole square, that is 2 less than or equal to 9. So obviously 9 is greater than 2 or 2 is less than 9, right? So 2 comma minus 3 belongs to the relation R. Now again you should put B is equal to minus 3 again. B is equal to minus 3 means now you put A is equal to minus 3. A is equal to minus 3 and let us put B is equal to 1. Okay. Let us put A is equal to minus 3 and B is equal to 1, right? So let us check it now. So it should also belong to the relation R. यो पनि relation R मै हुनुपर्छ. यो त given हो. यो त हामीले चेक गरेर हाल्नु पर्यो, हैन? So therefore A less than or equal to B square. So or what is A here? Minus 3. Minus 3 less than or equal to, what is B here? It is 1 whole square, right? So or minus 3 less than or equal to 1. That means 1 is greater than minus 3. Yes, it is correct. That means minus 3 comma 1 belongs to the relation R. Now can you say that 2 minus 3 belongs to R, minus 3 comma 1 belongs to R? Can you say that 2 comma 1 belongs to the relation R? Let us check it now. Now you have to prove that. You have to check 2 comma 1 belongs to the relation R. Let us check it. So this is the relation A less than or equal to B square, or now this is 2 and this is 1, right? So here you can put A is 2 less than or equal to, what is B square? This is your 1 whole square. So, or this is 2 less than or equal to 1. Is it correct? No, 2 is not less than 1. That means 2 comma 1, your 2 comma 1 say it does not belong to R. So 2 comma 1 does not belong to R. So it is not transitive. So therefore R is not transitive. Therefore R is not transitive. Therefore R is not transitive relation. So it is neither reflexive nor symmetric nor transitive. So we have proved it. Okay, so you can copy it. Now we'll do the next problem. So now we'll do the next problem, that is question number 6. Check whether the relation R defined in the set capital A is equal to within second bracket 1, 2, 3, 4, 5, 6 as the relation R is defined as R is equal to within first bracket A comma B, B is equal to A plus 1. Here the relation is given between A and B. That is B is equal to A plus 1 is reflexive, symmetric or transitive. You have to check it. R may be reflexive or not. R may be symmetric or not symmetric. R may be transitive or not transitive. You have to check it. Okay. So now for reflexive relation. For reflexive relation, what is the definition? A comma A should belong to the relation R. That means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 should belong to the relation R. Okay. So let us check it now. So therefore 1, 1. Let us check it now. So we have here B is equal to A plus 1, isn't it? So A is equal to 1 here. 1 plus 1 is equal to B is also 1 here. Is it true? No. This is wrong. A not equal to 2. So therefore 1, 1 does not belong to the relation R. Okay. The relation R is not reflexive relation. So therefore the relation R is not reflexive relation. Reflexive relation. So I think you have understood it. Okay. So next, let us check for symmetric relation now. Now let us check for symmetric relation. So what is symmetric relation? You know the definition. If A comma B belongs to the relation R, implies that ulta B comma A should belong to the relation R. Okay. So let us check it again now. A comma B should belong to the relation R. So if you take A is equal to 1, B is equal to 2. So 1, 2 belongs to the set A, right? So here in this case 1, 2. 1, 2. That is, if you put A is equal to 1, 1 plus 1 is equal to 2. So that is 1, 2 belongs to the relation R. Now check whether 2, 1 belongs to the relation R. About 2, 1. About A ko jagama 2, B ko jagama 1 lekhnu. So now let us check for 2, 1, right? So now A is equal to 2 here. Yo A ko value, yo B ko value. Now A is 2. 2 plus 1 is equal to, what is B here? It is 1. So are they equal? No. That means 2, 1 does not belong to the relation R. So 2, 1 does not belong to the relation R. So what can we say about the relation R in this case? It is not a symmetric relation. Therefore, the relation R is not a symmetric relation. The relation R is not a symmetric relation. So I think you have understood it. So you can copy it. Now we will check for transitive relation. So you can copy it. So now let us check for transitive relation now. Now transitive relation. Okay, so let us check for transitive relation now. What is transitive relation? You know that A comma B belongs to the relation R and B comma C belongs to the relation R. It should imply that A comma C belongs to the relation R. Okay, so this is the definition of transitive relation. Now A comma B, if you put A is equal to 1, B is equal to 2. Okay, if you put A is equal to 1, 1 plus 1 is 2, that is 1 comma 2 belongs to the relation R, right? So here we can write 1 comma 2. Let us check it. This is 1 plus 1 is equal to 1 plus 1 is 2, right? That is A comma B, 1 comma 2. So here 1 comma 2 belongs to the relation R. Is that clear? So now if you put, you should put A is equal to 2. You should put 2 for A now. 2 plus 1 is equal to 3. 3 is here. Okay. So now let us check for 2 comma 3. So now let us check for 2 comma 3. 2 plus 1 is equal to 3. That means B ko value kati bhayo 3. So A is equal to 2. 2 plus 1. So it is 2 plus 1 is equal to 2 plus 1 is equal to B is 3. So in this case also 2 comma 3 belongs to the relation R. Now you have to check that whether 1 comma 3 belongs to the relation R or not. Whether 1 comma 3 belongs to the relation R. Now check for 1 comma 3. Right. You check for 1 comma 3. Here B is 3 and A is 1. Right. So 1 plus 1. This is A means 1. 1 plus 1 is equal to, here B ko value kati hunदैछ 3. So this is not equal to 2. 3 is not equal to 2. That means 1 comma 3 does not belong to the relation R. So यो दुईटा चाहिँ छ तर यो चाहिँ छैन भनेपछि this is not your transitive relation. Is that clear? So you can write here, if these two relations are there, that is 1 comma 2 belongs to the relation R and 2 comma 3 belongs to the relation R, it is there. Okay, but 1 comma 3 does not belong to the relation R. That means R is not your transitive relation. Therefore the relation R is not a transitive relation. Is not a transitive relation. Is that clear to all of you? I think you have understood it. So this is question number 6. You can copy it. So now this much is for today. आज हामीले 6 वटा example, मैले 6 वटा example देखाएँ. तिमीले घरमा राम्रोसँग रिभिजन गर्नेलाई फेरि try to analyze it. Okay, try to understand it, try to analyze it. Okay, तिमीले घरमा आफै पनि यही क्वेशनलाई फेरि रिपिट गर्दै हेर्नु. बुझ्यौ? तिमीले प्र्याक्टिस पनि गर्नु घरमा. यही क्वेशनलाई नै तिमीले राम्रोसँग प्र्याक्टिस गर्नु. So this much is for today. In the next online class we'll do more problems on this relations, that is reflexive relation, symmetric relation, transitive relation, as well as we'll do equivalence relation also. So this much is for today. Okay.